Hello, my name is Kimberly Riegel, and today I'm going to be talking about developing low-cost acoustical measurement devices for student research. So in this work, I developed 3 different measuring devices. The first I'm going to talk about is the impedance tube, and you can see that on the poster here in the top right. And this is used for measuring acoustical absorption of materials. So one problem that we have in acoustics is when you're trying to figure out how a certain material will behave in a room, you really have to know how much sound it's going to absorb. And so we have these impedance tubes that measure the absorption of each individual material. They're very expensive. They can cost about $50,000. And so we built our own in my lab using PVC pipe and 3D printed parts. We also used a teensy microcontroller in order to build a data acquisition system, which we then used some free MATLAB software that is specific to impedance tubes. And the whole setup cost approximately $125 in equipment. The second device I'm going to talk about is this basic logger, and that's the one that you can see in the middle. And it actually on the right there, this black panel, that is a solar panel, and then this is a weatherproof casing. And inside that, you can see all of the circuitry and the battery that we developed. And there's actually, it's a little hard to see on this picture, but you can see there's a little microphone at the top to record sound. This is a basic data recorder. It will measure LEQ, Lmin, and Lmax, which are 3 common environmental noise monitoring parameters. We did calibration using a very low-cost buzzer and saw good agreement with some of the laboratory, like the high-end sound level meters. And then the last one that I'll talk about is the one on the bottom. This is also used for environmental monitoring, but is a little bit more flexible because it uses a Raspberry Pi instead of the Raspberry Pi Pico, which is the one that the middle one uses. So it has more flexibility because it's basically a full computer. The drawback here is that it does have substantially more power requirements. And so you can see the 2 silver things inside that case there. Those are batteries. And so they have very large batteries, and then they're powered by this 60-watt solar panel that you can see over here on the right. All 3 have been preliminary validated by lab equipment, though in the future we'd like to do a more rigorous validation over a longer term to make sure that it maintains the integrity as it is in use. We also, for the 2 bottom here, I'd really like to make them more rugged so that they could be deployed for extended periods of time. So we need to weatherproof them and make sure that they are able to be mounted and so they can't be stolen or tampered with. And so those are some goals for future work. But overall, we've developed 3 really useful acoustic measuring devices, which allows for really accessible research. Most engineering or physics students see acoustics within their first year, which means that they can get right into this kind of research if they have the resources to do it. And so for a lot of community colleges or teaching colleges that don't have huge research budgets, this would be a game changer for people who would be able to do real research for very little money. Thanks a lot for listening to my poster today.